Hello everyone, my name is Priyanka and I welcome you all to my session. Let's read a question which says that what are coherent sources of light? Two slits in Young's double slit experiment are illuminated by two different sodium emitting light of the same wavelength. Why is no interference pattern obtained? And then we have to obtain the condition for getting dark and bright fringes in Young's experiment. Hence, write the expression for the fringe width. And if S is the size of the source and its distance from the plane of the two slits, what should be the interference fringe to be seen? So, first of all, what is a coherent source? So, the source is emitting waves of same wavelength or frequency having either zero or a constant phase difference are said to be the coherent sources of light. Two independent sources of light do not fulfill the requirement of the constant phase difference. Hence, the sodium lamps considered here are independent sources of light and are not coherent. Therefore, we cannot obtain the interference pattern. Now, let us find out the conditions for getting the dark and the bright fringes. So, for bright fringe, that is maxima, for bright fringe, we can say it as maxima. We know that the path difference here x is given by x d by d is equal to n lambda, which implies x is equal to n lambda capital D upon small d, where small d is the distance between the two slits and capital D is the distance between the slits and the screen. So here n is ranging from 0, 1, 2 and so on. Now for dark fringes, we call it as minima. The path difference x d by d is given by 2n minus 1 by 2 lambda. That means x is equal to 2n minus 1 by 2 lambda d by d. Okay, so fringe width is the separation between the two consecutive bright fringe or dark fringe. So let's just consider the bright fringe here. So this fringe width is given by beta, which is equals to xn minus x of n minus 1. That means n lambda d by small d minus n minus 1 lambda d by d. So the common terms we're going to take out n minus of n minus 1. So lambda d by d into 1, that is lambda d by d. So that is the value of the fringe width. Now the condition for the visibility of the interference fringes is what we have to find out. So this is how the image is supposed to be formed. So S is given to us, that is the size of the source and the distance from the plane of the two slits. So let's just say that it is formed here and this angle is given to us as delta theta. This is B and this point is, this distance is small d. So the condition is that delta theta should be less than equal to lambda upon B. That means S upon D should be less than equal to lambda upon B. As lambda is less than B, therefore the condition is S should be less than equal to D. Hence solved. So thank you so much for your time. Have a great day. Bye bye.